Let's come back to the three basic forms of system interconnections and see how the transfer function of the connected system depends on the transfer functions of the subsystems. Let's first consider again two systems in series, where the first system has transfer function h1 of s and the second system has transfer function h2 of s. We want to replace these two systems in series by one system h of s, which takes as an input the signal x and produces as an output the signal y. Then we see that h of s is equal to h1 of s times h2 of s. This is due to the fact that in the time domain the impulse responses of system 1 and system 2 would have to be convolved to yield the impulse response of the new system. Since a convolution in the time domain is a multiplication in the frequency domain, h of s is simply h1 of s times h2 of s. Next, let's consider two systems h1 of s and h2 of s in parallel, which means that they both receive the same input x, produce the individual outputs y1 and y2, which are then added to yield the output y. Replacing these two systems by a single system h of s, which, when receiving the input signal x, produces the output signal y, shows that h of s is equal to h1 of s plus h2 of s. This is due to the fact that y is equal to y1 plus y2, which themselves are equal to h1 of s times x and h2 of s times x. The last system interconnection is the feedback loop, and we are usually interested in the negative feedback loop. Again, we want to substitute the system interconnection with a single system h of s, which takes as an input the signal x and produces the output y. To derive this expression, we first denote the output of system h2 with y dash and the input to system h1 by e, where e is given by x minus y dash. Then we know that y is equal to h1 of s times e, which is equal to h1 of s times x minus y dash. Substituting y dash yields that this is equal to h1 of s times x minus h2 of s times y. This gives that 1 plus h1 of s times h2 of s times y is equal to h1 of s times x, such that y is equal to h1 of s divided by 1 plus h1 of s times h2 of s times x. This yields the final expression for the equivalent system h, which is given by h1 of s divided by 1 plus h1 of s times h2 of s.